Here's a problem from our notes. This is number 12 on page 10. So we are given this scenario with a fly and a mug and some hot chocolate and a marshmallow, and the first question we're asked is what the reference point is. Well, this is a position arrow. So the beginning of the position arrow is the reference. In this case, the marshmallow. State the fly's general position. Remember that they're talking about the two-dimensional or the R position. So we are given that value straight from the origin, right to the fly. That value, that distance is 54 centimeters. But every position has a direction. And in the case of general position, the direction is an angle, 38 degrees. Now, we are not going to put a positive or negative beside R. Instead, we let this angle do all of the talking. This is the direction. Next, we have to draw arrows showing the horizontal, that's X, and vertical, that's Y, positions. Okay, put your pencil at the origin. From the origin, draw along the X-axis first. Then, without picking up your pencil, you can draw along the Y-axis to get straight to the fly. Now, you don't want to do this. You don't want to draw the Y first and the X second. We are going to use a convention that says X goes first from the origin. Another thing to avoid, don't go out too far like this and then go up. If you go out too far, then you suggest the fly is located over here, which she's not. One final thing, we want to make sure that they point along the axes. So don't make your Y arrow tilted or anything like that. Okay, let's label X is horizontal, Y is vertical. Now we have to determine, which means calculate, those positions. Look at what we've got. We know the hypotenuse and we know the angle. We have equations that say adjacent equals hypotenuse cosine theta, and opposite equals hypotenuse sine theta. These are on the equation sheet, and we can plug in to find our answers. Here, the adjacent leg, well, let's see, is it X or Y? X is adjacent because X forms the angle. And Y is opposite because if you draw a line out of the angle, you'll run into Y. So hypotenuse is 54 centimeters. And then we add cosine of the 38. Likewise here, we have 54 centimeters and sine 38. And plugging this in gives us 43 meters for X and 33 meters for Y. But remember, every position includes direction. Is this 43 meters for X positive or negative? Is it left or right? It's to the left, so we would have to simply add the negative ourselves, manually put that in. Or if you prefer, you could say 43 meters left. But for now, I will put the negative. How about the Y? That 33 meters is directed upward, and I can see that from my arrow. So I should put a positive right here for the Y arrow. All right, let's move on. Number 14. This time we don't have any arrows. Instead, we have this coordinate axis, so there's an x-axis and a y-axis. Notice the units here in parentheses, centimeters. All right, the first question asks to state the fly's horizontal position, and it wants the form x equals. Okay, here's the fly, and where's the origin? Well, hang on. It's not the marshmallow anymore, because the marshmallow is not located at 0, 0. So this is no longer our reference. The reference has changed to the handle, the center of the handle. So if you look at the fly and then you trace down to the x-axis, what is the position? Well, it's halfway between negative 40 and negative 60. So negative 50 centimeters. Next, we need the fly's vertical position. So take a look, trace over to the y-axis to find where the fly is on the y-axis. What object is the reference point? We've just discussed this, center of the handle. How do you know what the reference is? You find it's located at the origin. The reference is always located at the origin. 0, 0. There's 0, 0. Okay, draw an arrow for the general position R. Well, we always start with our pen at the origin, and then we point to the fly, or to the object. We also have to make sure we include the angle or direction of general position. Every position includes direction, and in the case of R, that direction is theta. In the case of Y, the direction is just positive or negative, up or down. For X, the direction is also positive or negative, up or down. Okay, we're probably going to have to find R and theta. Yep, that's part F. So to find R, we can use the Pythagorean Theorem. Just to help out, let's draw the X arrow. Make sure you end where the fly is located, and draw the Y arrow. Okay, the Pythagorean Theorem says R squared equals X squared plus Y squared. So X is negative 50, but when you square the negative, it should go away, so I'll just leave it off. Y is 40. We solve for R, make sure to square root, and we get R equals 64 meters, or let's see, centimeters is the unit. On to theta. The same way that I dropped the angle here, and first let me write my formula, inverse tan of opposite over adjacent, because theta is TOA, opposite adjacent. So opposite in this case, look up at the triangle. Opposite is Y and adjacent is X. So again, Y is 40 centimeters. X was 50 centimeters. But you can drop the negative signs because we are looking at a right triangle. It wouldn't make sense to have a negative angle here, so we won't worry about negative values of theta. We'll make every theta positive. Notice that the centimeters cancel, and if we plug this into the calculator, we should get 39 degrees. We're going to flip to the next page and wrap up that last page. Here we are on page 12. Let's go through how to draw position arrows. Start with your pencil at the origin, and then from there, move along the x-axis. So to get to the fly, we have to go leftward along the x-axis. Draw the arrow tip, and then, continuing on, move along the y-axis. Notice that we don't want to do y first and x second. This is valid, but it's not the convention we'll follow. We will always draw x first and y second. Next, we put our pen back at the origin. Start from the origin and draw a straight line directly to the fly and label that R. Mark the angle and call that theta. Take a moment now and try 2, 3, and 4, and then I'll pause the video and reveal the answers. Try these on your own. Here they are. Something to notice, theta is always marked between x and r. It's always between x and r, and theta is always marked at the origin. So theta tells us the angle of the R arrow as measured from horizontal. I'll pause the video and show you the incorrect versions of these, so make sure your answers did not look like this. So again, this would be an incorrect drawing for 2, 3, and 4. Instead, we want to put the x first and y second. What I messed up and did here was I put the y first and the x second. Thanks for watching.